Good afternoon, YouTube. How's everybody doing out there? So I've been doing a couple of YouTubes pertaining to the grade 7 and grade 8 math of New York State, both for a couple of reasons. One is just give people sampling. The other is it's kind of a pre-SHSAT thing because I keep getting questions about that, especially lately. So I figured I'd do some YouTubes leading people somewhere. We did 3 already on grade 7. I'm going to probably do 3 or 4 on grade 8. And then see where we should go from there at that point. My name is Greg. I'm from GregsTutoringNYC at gmail.com. You look down below. If you subscribe, you can find out some of this. Even though it's easy to concentrate on the grade 7 and grade 8 math, I cover all New York State state tests, including the ELA, the science, the math, social studies, whatever that happens to be. I do homework help. My forte is that I specialize in the specialized tests, whether it's for the SHSAT schools or Hunter College High School or Baccalaureate or Beacon or getting into some of the middle schools. Some of those have specialized tests, or at least for writing sections, which partly indirectly, even though they have those parts, also indirectly can pertain to because the admission to them involves getting grades, better grades on New York State things. Normally you need to be 90 percentile and above in your ELA grade and 90th percentile and above in your math, New York State math grade, and in some cases both. So you want that as part of your toolkit, your arsenal, and how you address your perspectives on entering schools and things like that. So what I'm going to do now is we're just going to jump into the grade 8 stuff. Again, I'm just using sample questions from the New York State Sampler online. So hopefully I don't run into any glitches. So let me shrink me down and just start jumping right into this again. Because these take a lot of time to do. Okay, so once again, when you take a test, read the instructions, read the directions, look at the reference table. There's always a reference table page in the beginning of all the New York State math tests. Okay, they don't always have this, but this is applicable for grade 8. If you looked at the ones for grade 7, there's a couple more formulas here. There's probably maybe something, 1 or 2 things going on over here that's additional too. All right, so let's jump right into question number 1. Let's see what they have here. Okay, it's going to be scientific notation conversions, it looks like. Let's read this as a word problem. Let's see where we need to go with it. The combined volume of all the tanks of an aquarium is 1.25 times 10 to the 6 gallons. The aquarium plans to install a new thing. Just give me 1 second to make sure I'm live here. Yes, I'm live there. And give me just 2 seconds. I should have loaded this. I'm going to check on my phone to see that this is actually going. So otherwise, there's no point. I'm just talking to myself for an hour. Part 4. Just give me 1 second to make sure I'm alive here. Yes, I'm alive. Okay, it seems that I'm alive. So let me put my phone over here for a second. And I'll just keep that running on the side. Okay. The current aquariums they have is 1.25 times 10 to the 6 gallons. The aquarium plans to install a new dolphin tank with a volume of 250,000 gallons. What will be the total volume of all the tanks at the aquarium after a new dolphin tank is installed? Okay, so we're talking about 2 volumes that need to be added basically, because it's asking for the total of all the volumes. So we know there's multiple tanks. Some of those is 1.25 times 10 to the 6. And we know there's at least 1 more coming in, which is 250,000 gallons. And what is the volume of them all? So we need to add these together. So let me get a notepad up here. There's at least 2 ways to do this. So let's start exploring. So we have 1.26 times 10. I'm going to use the shift 6 to mean exponential notation because the notepad doesn't have this capability. I'm not sure why they don't have that because and some of the other answer things they do. But in the event, this means 1.26 times 10 to the 5. And I'm doing my normal typing errors here. It's actually 1.25 times 10 to the 6th plus 250,000. That's basically what we need to do. Okay, so one of the problems, a lot of the calculators don't have scientific notation. Not sure if this one does. Let me see here. No, I'm not seeing it in any obvious way. Let's stick that on the side for now, because we may need the calculator. So what we need to do is figure out what some of this stuff means. So let's because 250,000 is still 250,000. Let's try to figure out what 1.25 times 10 to the 6th is. So the powers of 10 are nice. 10 to the 0, or anything to the 0, is 1. And 10 to the power of 1, 10 to the 1, is equal to 10. And 10 squared is equal to 100. So there's something interesting that happens with powers of 10. The exponent is the number of zeros. So if I said 10 to the 3rd, what we're talking about is writing the number 1, not the number 10, and then adding 3 zeros. So we have 10 times 10 is 100, times 10 is 1,000. So if I have 10 to the 99, I'm going to write 1 and then 99 zeros. All the dots together and so on is going to end up with 99. So in the example they're giving, and let's rewrite that. I'll rewrite that so it doesn't shift off. I don't know if I can copy and paste this. Let's see. No, it doesn't. It doesn't let me do that. So let me retype it. Oh no, it did. Okay, so 10 to the 6th is equal to 1 with 1, 2, 3, 4, 5, 6 zeros after it. Okay, and it's 1.25 of that. So what we're going to do is write the 1.25 underneath it without the decimal point. 125, 125, and then we're going to fill in the rest of the zeros. Okay, so this is equal to 1.25 times 10 to the 6th. Okay, so if we have 250,000, which was the other number, okay, what we're going to do is add them up. There. And what we're going to get is 150. That didn't line up exactly because the digits don't use the same proportional font face things, proportional fonts. So we're going to get 1, 2, 3, 4, 150, 1, 2, 3, 4. Did I do that right? 150, yeah. So we're going to get this. And we can revert it back the same way, because this is the same as 1.5 times 10 to the what? So let me get out my handy dandy thing here. And if we go backwards, we're going to start from here. So we're going to go 1, 2, 3, 4, 5, 6. So we moved the decimal point 6 places. So it's going to be 10 to the 6th. So we get 1.5 times 10 to the 6th, and that will give us C. Okay. There's another way to look at this, which is that we can map, we have the two numbers again. Let me see, they should still both be here in my buffer thingy. Okay, so how about we take the 250,000 and map that into decimal notation. So we get 2.5 times 10 to the what? So if you move it 1, 2, 3, 4, 5, I believe that's 5. Let me see if this works for a second. I think I can expand my thing yes here. So if we go 1, the four zeros plus the 5 brings us 5. So that's the same as that. Okay, that helps us because now we can convert this 2.5 times 10 to the 6th equals what times 10 to the 6th. Okay, we can do that conversion. Okay, what I'm going to do is underneath this, I'm going to force this to be 10 to the 6th. Okay, so what it means is I multiplied this, and I'm going to circle it. I multiplied this by 10. That's how I got 10 to the 6th. So what you need to do is come over here and divide this by 10. Because this is a multiplication. If I have a times b and I multiply b by 10, I have to divide a by 10 for it to still be equal. Okay? So 2.5 divided by 10 is 0.25. Okay? And now what that means is if we change the example, this becomes plus 0.25 times 10 to the 6th. What we have is now we have common terms, basically. We have 1.25 times 10 to the 6th, and we have 0.25 times 10 to the 6th. So we get 1.5 times 10 to the 6th. So we have two ways to double check that the answer is C. Okay? Okay, just make sure I'm doing good on the phone. Yes, I am. Okay, so the answer is C. Let me just check that that is the answer. Okay, C, yes. Okay. Okay, what's our next grade 8 question? Ah, graphs. Everybody cringes on these. So what we're going to do is, using my normal route, and this gets harder because this is a harder illustration. We're just going to look at the illustration and make observations. We have XY coordinate. We have the four sectors, quadrants, and we have two lines going through them. And the two lines intersect at some point. So maybe that's the question. We may have to ask for the intersection point. We may have to look at the slope. We may have to look at a whole bunch of things. So there's not really much else going on here. We can stop playing with the numbers, but at this point it's too slippery because the question can go back and forth. So at least we understood it. There's two intersecting lines in an XY plane. Okay? So the graph of a system of equations, because remember a line is an equation, y equals mx plus b, that form, or there's other forms of a line too, but y equals mx plus b, hopefully that's what they're going to shoot for. And it says, what systems of equations represent the graph? Okay, so let's see what we have here. Okay, so what I'm going to do is observe A, B, C, and D first, just to get a sense of where things are. So I'm noticing they're all in the form y equals mx plus b. Even this one here, the y equals 1/3 x, is also because b is 0 then. Okay? And even say on D, y equals minus 2x, that's fine. So they all seem to have, they're flipping between slopes of 2.5, and they're all negative slopes. Okay? And they're also flipping between slopes of minus a third. We can see, looking at the graph, that because the slopes are both are this way and not this way, okay, this is normally a plus slope, and this is a minus. Okay, and this example doesn't help us because in all the examples, they're all negative slopes. So that's cool. So it doesn't help us rule out A, B, C, or D, but it confirms we're understanding what we're even being asked to do. Okay? So what we can do is I'm just going to pick one arbitrarily. I'm going to do this one first. Okay? So what I'm going to do is I'm going to bring up a notepad, and we're going to figure out the formula for that line. I'm going to have to bring up the notepad, I guess. So we're going to have y equals mx plus b. Okay, for that first line, we know b is 10 because that's the y-intercept. When x is 0 on that line, y is 10. It's showing to us. We could actually see it right there, right? That's what this point right here is, where it intersects the y-axis. Okay. So far we have y equals mx plus 10. So we could snoop at the answers if we want. Okay. And it looks like every scenario has one of those. So we can't rule out anything yet. Okay. So now what we need to do is figure out the slope. So m is the slope. And one way to figure that out is the rise over the run. The slope is the rise over the run, and the rise basically is the difference between the y's, and the run is the difference between the x's, right? So the x-axis goes horizontal, so you would run normally horizontal, and you would put a ladder and go up and down, rise up and down on the y-axis. Okay? So what we're going to do is take some strategic points on that line. So for y, we're going to use the coordinates. Let's see, we're going to have 0, 10, and it also meets that same line, the x-axis, at 5, not 1, 2, 3 and a half. Notice those are counting by 2, 2, 4, 6. So at 5, 0. Okay, so if you do the rise of the run, it actually doesn't matter which order we do it to. We're going to get minus 5 over 10. Or if you do it the other way, you're going to get 5 over minus 10. In either case, we're going to get minus a half. Okay? So we have that's what we have. So we have y equals, I'm going to use 0.5 for now, just because it's easy to write. 0.5x plus 10. All right? So is that matching any of these? Sorry, and it's minus, because we had minus a half over here. So we have minus 0.5 plus 10. That seems to match C so far. Did I do that right? And let's try to do the other one now. No, I did that wrong. It was supposed to be, these two need to be flipped. Okay, I subtracted the x's and put them on the top. It's supposed to be subtracting the y's. So will we get minus 2? My bad, my bad. Okay, and it just shows you need to keep track of what's going on here. So basically, let me do this over. We would get minus 10 over 5, or 10 over minus 5. And that gives you minus 2. Okay, so we get y equals minus 2x plus 10. So that gives us choice A or B. Okay, it rules out C and D so far. And we're going to do the same thing with the next line. We're going to get the y equals mx plus b. We already see in that line that it passes through 0, 0. So when x is 0, y is 0. So we know we have no b basically. So what we need to do is figure out the slope of that line. So it's either going to be a third or a half, because these two are the same otherwise. So we're going to have to see what's going on there. So let's use our coordinates. One we have 0, 0, and the other we have is 12, minus 6. So if we work our way down, we got 12 minus 0 is 12. I'm making the same mistake. The rise over the run. Minus 6 is minus 6 minus 0. That gives us that. And divided by 12. So we get minus a half. Okay. We could have done it the other way as well. And gotten, instead of minus 6 over 12, 6 over minus 12. We could have done 0 minus minus 6 and 0 minus 12. Okay, both gives us minus a half, so we end up with B. Okay, this one's hard to double check. You just have to make sure your slopes are right. Like I did right here, I made that stupid error. That's an error. That's not correct. Okay, let me just double check. Grade 8, question number 2 is B. Okay, good. Question number 3. Let's see what we got going on here. So what I'm going to do again is only look at the table first. Just figure out what's happening there. So I have an input and an output. It says I can figure out a pattern that it's plus 4 on the y. 5 plus 4 is 9. Plus 4 is 13. Plus 4 is 17. And it seems to be plus 2 on the x. Minus 1 plus 2 is 1. Plus 2 is 3. Plus 2 is 5. I'm not sure what they're doing here with the input and the outputs. And when I see x and y, I don't know whether to put any meaning to them. But the first line that says the table represents a linear function, it's just staring at me. Okay, so it seems that this means if we put a notepad up here, drag that over. Let's see if we get anything that makes sense. So if it's a linear function, y equals mx plus b, and the y's and the x's are the y's and the x's here. So it seems the x's and the y's are coordinates. So we would have minus 1, 5, and also, for instance, 9, 1. Okay. Nope, I wrote that backwards. 1, 9. So if we do our rise over run again, we get 9 minus 5 is 4. Okay, for the numerator, and we get 1 minus 1, which is 2. So 4 over 2 is the same as 2. So it seems that our slope is 2. So if we have y equals 2x plus b, okay, does that actually jive? Let's stick something back in. So if we have 5 equals actually I want to avoid negative numbers, but let's just use it anyway. We're going to have 2 times minus 1 plus b, and we're going to get 5 equals minus 2 plus b. To get b by itself, we're going to add 2 to both sides. The minus 2 plus 2 cancels out, and we get 7 equals b. Okay, so let's use the 1, 9 and feed that back in. So is that true if b is 7? So in other words, our line is y equals 2x plus 7. So let's use the 1 and the 9. So we get 9 equals 2 times 1 is 2 plus 7. Yes, so we confirm that this is the formula that we're shooting for. So this is the equation of the line represented by this table. Okay, so now what they're asking for is, let me get this out of the way. I can't get it out of the way. I think it's going to go off your screen for now. Yeah, it's a little bit off the screen. So which function has a greater slope and a greater y-intercept? Okay, so this becomes easy peasy if I'm understanding the question correctly. Which function has a greater slope? So it turns out if it's 2x, then 3x, 5x, and 10x all have greater slopes. And which has a greater y-intercept? Well, our y-intercept was 7. We can't. By the way, we can't use a for the greater slope because 2x and 2x are the same. So a goes thrown out. So we're left with b, c, and d. And b, c, and d all have a greater slope because it's 3x and 5x and 10x is greater than 2x. And which has a greater y-intercept? That's what b is. So we have y into 7. That rules out d because it's 5.5. That rules out c plus is 6.5. So that gives us b. Okay, so question 3 is B. Okay, good. And that seems to be all they're asking. All right, let's see. Question 4 is getting into a little bit of trigonometry and geometry. So triangle M is similar to triangle N. Okay, I'm drawing this as a right triangle. It doesn't have to be. It's similar. It's not congruent. Congruent means it's the same size and the same shape. Similar means that if we have this angle, then whatever it happens to be matches this angle. And if we have this angle, I'm putting 2 here. It's going to match what's here, 1, 2. And if we have this angle, 1, 2, 3, then this is going to have 1, 2, 3. So the single angle matches the single, the double matches the double, and the triple matches the triple. Triple in the sense of my notation here. Okay, so congruent means the same size, the same shape, the same angles. Similar means the same angles in the case of a triangle. Okay, so what we have is triangle M has 2 angles which measure 32 and 93. So let's just say for argument's sake this is 93. And this is 32. So the question is, which 2 angle measures could be included in the other triangle? So there's an easy peasy way out of this, which is that you have to know a fact. The fact is, let me bring up my handy dandy notepad again. Wait, I have to get rid of this. Which is that the sum of the angles in a triangle is 180 degrees. Okay? So if we have 32 plus 93 plus we don't know the other one, it's going to equal 180. So let's just do the simple math. 93 plus 32 gives 95, so I get 125, I believe. Plus x equals 180. So we subtract 1 to 25 from both sides. And we get x equals, I believe, 55. And let's bring up our calculator just to do that. So what do you have? 93, 32, 90, yeah. 32 plus 93. Right, that was 125 minus 180 gives us 55. Okay, I did the computation backwards, got minus 55, so that means it's 55. So those are the three angles in the triangle: 32, 93, and 55. So so let's see what the other could be. Would it be 32 and 58? No. Would it be 32 and 74? No. Would it be 93 and 55? It could be. Would it be 93 and 87? No. So question number 4 is C. All right? So that was pretty much an easy peasy one, especially compared to the previous one with the graph and all that. Okay, question 5. Okay, we have a word problem. There's a bunch of numbers that are leaping out at me, so let's see what we have. An above-ground swimming pool. So it's not in the ground, it's above ground, we kind of don't care. Is in the shape of a cylinder. Cool. So a cylinder is the shape of, say, a soda can. Has a diameter of 18 feet and a height of 4.5 feet. That the pool is filled with water to 6 inches from the top. What is the volume of the nearest cubic foot of the pool? All right, so there's a few things we need to keep track of. If we go back to our reference table, okay, we're going to see the volume of a cylinder is pi r squared h. Pi r squared h. So the volume equals pi, I'm just going to use that, times r squared times h. Okay. The diameter is double the radius. So therefore the radius is half the diameter. And in this case, since the diameter is 18, the radius is equal to 9. Let me just double check it. Is that right? Is the diameter of 18, that radius is 9. Okay, cool. So our volume is going to be pi times 9 squared times the height, which is going to be pi times 81 times the height. Okay, it's easy. So we're looking at, it says the height is 4.5 feet, but it's only filled up to 6 inches from the top. Therefore, the height we're using is 4.5 minus 6 inches, which is 0.5. It's half a foot. So therefore, the height is equal to 4 feet. So that's pretty much where we're at. So we have pi times 81 times 4 feet. So let's go into the calculator and do it. Let's just look at the question, make sure I did all that right. You have an above-ground swimming pool in the shape of a cylinder, has a diameter of 18 feet and a height of 4.5 feet. So we're doing 18, the radius of 9, 9 squared, pi r squared h. Okay, good. So we're going to have 84 times, where are we? Is the calculator. Again, we're going to not use 3.14. We're going to use pi, especially when it says it wants it rounded to the nearest cubic foot. So let's bring that back a little bit. Where was pi? Where was pi? We found it before. Right there. Pi times 81 times 4 equals, and that becomes 1.0.17.87602. And it wants it to the nearest cubic foot. So we're going to bump it up. So let's see if that's what the answer is. Right. So we get 1, if we round this, 1.18. And it turns out to be C. Let's see, question 5 is C. Yes, it is. Question number 6. Okay, we're going to start out. We're just going to look at the table. And let's see what we got going on here. There's some sort of eyesight study. It's a XY coordinate in just the one quadrant for now. There's a bunch of dots there. It looks like it's a scatter plot, maybe. The bottom talks about years. It's going from 0 to 75. If you notice over here, there's a couple things we need to observe here now. There's a little break here because it starts at 0 but actually skips right to 90 and 100 and also skips on the x-axis to 20. Another thing to note is that the y-axis is going by 2s, okay, and the x-axis is going by 5s. So there's different ratios happening here. Okay, so the age is by 5 and the vision score, whatever that happens to be, is by 2s. So I'm assuming people are getting eye exams and say at age 50 their thing is about 105. I don't know if this is to scale. And I'm trying to look at some dots because 25 look like it's 108, but the dot actually looks slightly over, so it might be 26. And something like age 31 also seems to be 108. So I don't know what else to do with this. So let me go back to the words. Remember, there's words on the top here and words at the bottom. So we need to read both, right? There's words up here and there's words down here. This is how they always do it. If you only read the bottom stuff, you're going to miss out info. Okay? So a researcher studied the eyesight of people at different ages. Okay, that jives. I'm seeing that at the bottom. That's the x-axis. She calculated a vision score for each person in the study. Okay, that's on the y-axis. And plotted the data in the graph on the graph below. All right, cool. No problem. The researcher used the line y. Let me use the highlighter back here for this. Use the line. So if we notice, that's in y equals mx plus b form to model the data. Once she substituted the value x equals 65 into the equation, what did the result tell her? Okay, so let's bring up a notepad. Actually, what are some of these answers here? Min, max, predicted, and exact. All right, so let's plug that in and see where it leads us. Let me see if this stays on the screen. Give me 1 second. It's kind of falling off, and we are still okay on my phone. All right. 1 second. So we have y equals minus 0.1x plus 110. They're telling us x is equal to 65. So we're going to get up there, we're going to get equals minus 0.1 times 65 plus 110. And this equals minus 6.5, right? Plus 110. Whoops, that should be 110. And that gives us, what, 103.5, I believe. If I did all that right. Y equals minus 0.1x plus 110 to model the data. X is 65. 65 times 0.1 is 6.5 and negative. So negative 6.5, 103. Yeah, there we go. So that's the numbers we're playing with here. So, what did the result tell her? The exact value for the vision score of 65? Well, 65 is telling us it's 102, and that was the calculation that she actually saw. But the formula says it's to model the data. Okay, so A doesn't seem to be right. It's not the exact value. And in fact, if we look at here, it's 102. The exact value is 102. So this is just the modeling. B, predicted value for the vision score of 65-year-old. Okay, B sounds better to me. So that's the best answer so far. The minimum or the maximum value? No. If it was the minimum, these C and D just kind of they're opposing each other. And if it was the minimum, then it would also have to be the maximum. And vice versa, it was the max would have to be the min. So C and D just cancel out, and we know, given what we know about lines and yada yada, that it's not C and D anyway. So it's a prediction. That's the model. It predicted 103.5. The actual measured result was 102, and that's cool. So 6 should be B. Yes, it is. Okay. So now we're going to come to question 7, which is a show you work. This is a 2-pointer. We're going to look at the illustration again, not the words. So what I see is some sort of eggs or ping pong balls or something. Yeah, I'm going to go with ping pong balls because they look symmetrical. And they're inside of a let's say, in this case, a glass enclosed 12 by 12 box. Okay, we don't know the height. And I'm looking at it, and I'm saying, if the spheres are all the same size and shape, then I'm noticing that there's 3 across and 3 across. Okay? And that means if it's 12, that each one of them, from tip to tip, so from here to here, right? And then again from here to here, right? And then from here to here. It's going to take 4. And I notice it's working the same way along here. So it seems to me the diameter of this it was taken as a circle. It's a sphere though. Is 4. But when we line them up, we know we have 4, 4, 4. Okay? And that's about all we can figure out from this. Well, I also said before, we can also figure out one more thing. The height here, it turns out, is also 4. If the spheres. Okay? That's the height. Okay, so now with all that in mind, let's go back to the words. A box contains identical 9 glass spheres that have been used to make snow globes. Okay, so they are all supposed to be the same size and shape. So that means everything we talked about here with the D equals 4 is correct. The spheres are tightly packed, so there's no space between them. So that the 12 by 12, which means again that the 4, as shown below. Okay, what is the total volume in cubic inches of all 9 spheres? Round your answer to the nearest tenth of a cubic inch. Oh, lovely. Okay. And they're helpful. They're actually giving us the volume formula. So it's 4/3 pi r squared. Okay. Since d was 2, sorry, if d is 4, therefore the radius is 2. The radius is half of that. So what we're going to have is 4/3 times pi times r cubed. Okay, now it's letting us do that. So pi is pi, 4/3 is 4/3. Since r is 2, then 2 times 2 is 4, and times 8. So what we're going to do is replace r cubed by 8. And now we have 4/3 times pi times 8. So we get 32 times pi and that divided by 3. I know that 3 on the side is falling down. I'm trying to do this, just do this quick enough. So we kind of have a note here already that we have pi. We know pi is 3 something, and we know we have a division by 3. So the answer is going to be about 30 something. Okay. So let's go into our calculator and actually figure out what it is. So we're going to have 32 times pi. Where did pi go? Where are you at, pi? Pi divided by 3, was it? And we get 33.51 something. By 1 something. I'm not going to write it down. Okay, so our answer, if we notice in the box below, it's going to be in cubic inches. So this would be 33.51 cubic inches. So what I like to do before I put my answers down is go back to the question. In fact, I know we're missing something here. There's another part here to it. So let's reread the whole question and see if you can decide where the missing part was. So a box contains 9 identical glass spheres that are used to make snow globes. The spheres are tightly packed. What is the total volume of all 9 spheres, not just one of them, by 9 of them? So if we go back to the calculator, multiply that by 9, we get 301.52. Where's my, so we get 301.529 something or other. Is that what it said? 592. Yes. And if we come back to here, it wanted the answer rounded to the nearest tenth of a cubic inch. So that means the answer actually is 301.6. Right? Let's just see that we're going good here still. Yes, we seem to be. Actually, let me just quickly bop into here, see if anybody has any questions. Nobody has any questions. All right, good. Okay, we'll go to question number 8. A customer is comparing 2 different text message plans at cellular bargains. He wants to find out which plan allows the most text messages. Let me sip this for a second. For the same cost. The pay per text plan charges $10 per month and 10 cents for each text message. Write a function that models those plans, stating what your variables represent. So if the cost is going to be $10 plus 10 cents for every text message, and so that's my formula, and I want to say C equals total monthly cost. It has to say monthly because it talked about $10 per month, and T is equal to the number of text messages. Let me just make sure that makes sense. I'm going to reread this all again. A customer is comparing 2 different text message plans at Bergen County. He wants to find out what plan. Okay, the paper plan. So this is the paper text plan that we're just writing here. Charges $10 per month and 10 cents for each text message. Write a function that models this plan, stating what your variables represent. Okay, good. Oh, we got some fun here, it looks like. The frequent text plan, so that's the other one, I guess. That was the paper text plan. The frequent text plan is modeled by the graph shown below. So what we're going to do is look at the graph. number of text messages, and the cost per plan per month in dollars. Oh, by the way, no, that didn't. That just wanted the formula. I didn't have to plug it in, so I don't know the dollars yet. And I see a line there, so it's going to follow the y equals mx plus b thingamajiggy. How many text messages would result in the same cost per month for the two plans? Okay, show your work. So what I'm going to do is copy. I'm going to copy this first. Well, and this is the paper text. Paper text. Is that? Did that work? No. C equals 0.1 t plus 10. And now what we need to do is figure out what the other one was. So we need to do the same kind of thing where we did in the other example, where we're going to figure out the slope of the line, I guess, here. All right. So can I do that here with everybody seeing it? Yeah, let's try to do it. I'll write across. Let me see how much is coming on the screen here. Yeah, we can keep writing across. Okay, I'll just put some stars here for a moment. That has no meaning to it, just separation. So we have, what I'm going to try to do is find somewhere where this line intersects, somewhere reasonable. It looks like right here is one place. So at 90.25, no, sorry, that's 100.25. So let me get rid of this for a second, come back down here. So we have one coordinate, which is going to be the x is 90, comma, and the y is 25. And there's a second one at 0, comma 20. So if we do the rise and the run, 20, 25 minus 20, is 5, and the other is going to be 90. Wait, nope, it wasn't 90, it was 100. It's going to be 5 over 100 then. Which is equal to 0.05. Did I do that right? Let's just double check that. We have 80, 100, 100, comma 25, and we have 0, comma 20. We subtract 25 minus 20, and we get 5, and 100 minus 0 is 100. And that's 5, yes. So that gives us y equals, or in this case, the cost of that one equals 0.5, or just 0.5. 0.5, no, sorry, 0.05. In that case, text of that plus 20. Okay, so now that we have that, we can scroll this up now. So what we need to do is make the both of these equal. So we're going to have 0.1 t plus 10, because we want to see the number of text messages, equals 0.05 t plus 20. What I'm going to do is try to get the t's by themselves. I'm going to take 10 off of here, take 10 off of here, so I have 0.1 t equals 0.05 t plus 10, and if we subtract 0.05 t from both sides, minus 0.05 t, we end up with, I think, 0.05 t, because 0.05 t plus 0.05 t is 0.1, equals 10, And what I'm going to do is multiply both sides by 10, and I get 0.5t equals 100. Multiply by 10 again, and I get 5t equals 1,000. Or t equals 200. And we can do that with the calculator just to be sure, because what we're doing is dividing. Basically going to divide both sides by 0.05. So if we're bringing the calculator, where did the calculator go? Where is the calculator? It's not bringing it up. Let's try to see if it lets us bring it down there. Right, so if we get 10 divided by 0.05, we get 200. Okay, so let's get rid of the calculator for a second. That's going to give us 200. Let me just make sure that that's what the problem is again. The frequent is modeled in the graph. Okay, so this is a 3-point problem, I believe, and it hinges on this being correct. If this is incorrect, the highlighted in the blue line right now, if that's incorrect, then when you come to do this, you have a carry-on error. So if your procedure is right and so on, you'll get the points for this. You just won't get the full points because the other one was wrong. Okay, so if you have a carry-through error, as long as your procedures on the second part is all right, you get the extra points. All right, so let's go to the next question, and there is no next question. So let me come back over here and bring me back in all my glory. All right, so we did 3 7th grade samplers. We did an 8th grade sampler. It's just par for the course. I'll try to do 2 more of these. I don't know if I'm going to get any more done today or not, but let's see. Again, I'm Greg from GregsTutoringNYC at gmail.com. I do a lot of tutoring, so let's just end this because it's a long time. And happy mathing. Take it easy, everybody.